A very warm good morning to one and all present here. I request the dignitaries to please occupy the days. Marshal Amir Kumarji, Jyoti sir, Dr. Kumar Jata sir, and others. Please. A very warm good morning to one and all present here. It's indeed a moment of pride and honor to have you all amongst us. We are all present here for the GIAN course on aerospace materials, microstructure, fracture and fatigue. We have amongst us today the distinguished chief guest, Air Vice Marshal Anil Kumar Gupta ji, the course instructor and the faculty for this course, Dr. Kumar Jata sir. We have amongst us the senior faculty of the Department of Material Science and Engineering, Dr. Jyoti Mukhopadhyay, and the host and coordinator for this course, Dr. Amit Arora. Can we have a round of applause for Anjali? I would like Anjali to please come on the dais. I request Professor Dr. Jyoti Mukhopadhyay to please welcome Air Vice Marshal Anil Kumar Gupta. I request Dr. Amit Arora to please welcome Dr. Kumar Jata sir. So this GIAN course on aerospace materials, microstructure, fracture and fatigue will focus on various microstructures that can be produced in structural materials, particularly in aluminum, titanium and nickel-based superalloys, and how one can manipulate the microstructure to produce the desirable properties. The product forms and heat treatment tempers needed for aerospace industries will be discussed along with the lessons learned. There will also be an emphasis on use of aluminum alloys in the automotive industries and shipbuilding industries as well. I would like to call Dr. Amit Arora to please introduce the dignitaries. Sir, please.
Thank you, Anurag. Good morning, everyone, and welcome to IIT Gandhinagar campus for everyone who is coming here for the first time. I hope you have a good stay here. We have this global initiative for academic networks, which is a program initiated by Department of Science and Technology and Ministry of Human Resource Development to have more interaction with the academic persons around the world and use their expertise to build the knowledge networks in our country. And under this scheme, we are now organizing this GIAN course on aerospace materials, microstructure, fracture and fatigue. The course is very relevant in these times because we are emphasizing on Make in India. We are trying to build our capacities to make things in India, and to make things in India you need two things. You need material and you need manufacturing, and both these aspects will be covered in this course, and I hope you will learn everything which we can from Dr. Jata, who has a lot of experience in this area. To inaugurate the course, we are honored with the august presence of Air Vice Marshal Anil Kumar Gupta, who is a Visis Seva Medal recipient. He did his graduation in mechanical engineering with discipline with honors from Thapas. He was commissioned in aeronautical engineering in mechanical branch of Air Force, Indian Air Force in 1982. and he has completed postgraduate from IIT Kharagpur, where we share a connection, sir. We are both alumnus of IIT Kharagpur. He completed his postgraduate in 1994, and he is also alumnus of Defence Services Staff College and Naval Higher Command College. He has undergone training in France on Mirage 2000 aircraft systems. AVM A.K. Gupta presently holds the post of Senior Maintenance Staff Officer at Headquarters Southwestern Air Command located at Gandhinagar. And during his distinguished career of 35 years, he has in the engineering branch of Indian Air Force, he has held various important staff as well as field appointments. And by virtue of his training and his staff appointments, he has extensively interacted and worked with Air Force and aerospace industry of Europe, US, and South America. The Air Officer has been instrumental in undertaking many innovations and in-house repairs, which has resulted in substantial savings to the Government of India. The Air Officer is also a recipient of the Presidential Award, Vishish Seva Medal, and commendation by the Chief of Air Staff. Please join me in welcoming Air Vice Marshal A.K. Gupta. So may we have a few words from you to the audience, please?
Very good morning, all the dignitaries and dear students. In fact, it's my privilege today to be here with all of you and be part of this, what you're calling it, seminar or workshop. In fact, I shall not speak on materials because I have been given to understand that who's who in the field of materials in the country is here. And we have Dr. Kumar here, who is the expert. I can only share with you that as an Indian Air Force personnel, how important it is for us. Each and every kg of material reduced on an aircraft is that much more payload. And I think I won't be exaggerating if I say that aerospace material is, I think, one of the most important ingredient of the aircraft. I can just give you an example. Helicopter, what we have from the highest airfield, can you imagine what will be its payload? Anybody from the students, material science students? The payload is limited to meager 50 kgs. And if you can reduce the weight of that helicopter by 5 kg or 10 kg, you imagine you have improved the output, improved the payload by 20%. So just 0.1% improvement in materials can give you an output of 20%. Where can you get such ratios? I think same is with the temperatures. The way we are improving the engine temperatures, the efficiency is multiplying like anything. So, but as I said, it will not be correct on my part to speak about materials here. Definitely, I like to flag that, of course, operations is one thing. As a maintenance man, I will like the material to be maintenance friendly. You can, if you interact with Air Force people working on tarmac, and particularly the old generation Russian fleet, they are bogged down with fuel leaks, hydraulic oil leaks, and the amount of work which they have to undertake in repairing those leaks. We are aware that a small hydraulic pipeline, if it's just bent by 2 to 3 degrees more, the kind of stresses it generates, and when you connect it, it's likely to give way after some time and likely to result in leaks and maybe at times catastrophic failure. Your hydraulic systems going off in the air can be catastrophic. So, not only for operations, for maintenance man also, the materials are very, very important. In Indian Air Force per se, how we deal with the materials, what I can share with you, what I can recollect, I think. We do a lot of reclamation. So when the parts are they worn out, we try to give them a coating and increase their life. And some of our this kind of work is done at base repair depots. So some of our base repair depots have got best of the reclamation technology in the country. I've been given to understand that the vacuum furnace we have at Kanpur, I believe, is the biggest in the country. And we have very beautiful plasma coating equipment, I think mostly from Switzerland, which is used for reclamation of engine parts, casings, etc. Of course, the various coatings and all, that's very common. Coatings are undertaken further for increasing the life. At Air Force Station Kanpur, we have very, very good infrastructure for these reclamation technologies. And I think some interaction between ATMIA and these BRDs can definitely make us recover some more spares which maybe we are throwing away now. I think that's all I have to say. I will leave it to experts now to go ahead with this course. One more thing I will like to share with you. In fact, not share, I really want to compliment the students of today. Recently, I was involved with Nirma University in organizing a small program there, and that's Know Your Air Force. The Defense Minister had come that time. I found that all of you are so constructive and so focused. I find vast difference the way we used to be in our days. So I am very, very confident that future of our country is in very safe hands. Generally it's the old people saying that our times used to be better, but I don't believe that. I believe that the student of today is much more smarter, much more focused, and much more constructive than what we used to be in 70s or 80s. All the best to you. God bless and wish this course Godspeed and happy landings. Thank you.
Thank you very much, sir, for your kind words and your encouraging wishes. I'll be very unfair if I let this opportunity go when we have on dais with us Professor Jyoti Mukhopadhyay, who is ex-director of Jawaharlal Nehru Aluminium Research and Development Center at Nagpur. and who is also a board member at Mishra Dhatu Nigam, Hyderabad. And he is the expert and one of the biggest supporter of light metal alloys in India, especially aluminum industry. So please join me in welcoming Professor Jyoti Mukhopadhyay to say a few words to the audience.
Good morning, the dignitaries of the dais, friends, and my students. And this is the right time that it has been arranged as aerospace material, microstructure, fracture, and fatigue, because we are in India that we know how difficult to make this aerospace material, which is actually used for in aerospace industry. And basic material still we are not producing in this country. That is the pure aluminum requirement is 99.9. We produce in this country 99.83. And we are not able to produce the basic pure virgin material. We are producing material, but not enough for aerospace grade. And those series still we are importing from abroad. So that's what I take when I take the class and I tell the students at least in my lifetime if you at least one component you make and you do the import substitution, it will help my soul. And we have to first see what is the basic material. That basic material we are not producing. After that, I'm just giving the example. If you produce, we are producing 99.7%. It is, but that is not good for at all for this aerospace industry. We need minimum 99. Moment you produce 99.9, that 120 rupees per kilo, it will be immediately jump to 240 rupees per kilo, and that. Further that you have to pay $50 premium, and now the best material that is we use, that aluminum lithium alloys, we have not produced in this country, although abroad in developed countries they have produced third generation alloy, and that alloy required for this like Augusta Westland helicopter that they have used. Similarly, Airbus 380 they have used, but we don't produce. This is the pledge. That's what we have to see. All of us. We have to make sure we make this material, and this material only available in developed countries. And those developed countries, they don't want to give the price. Price is heavy higher. Just telling minimum price maybe 600 to 800 rupees per kilo if you make aluminum lithium. Same 99.9, if you add 1% lithium, it will be immediately jack up to 800. Each aircraft takes a lot of tonnage of material. That's what I'm, but I'm happy to tell you, here they have started their research and they have made some kg level, and we are not, unless we make ton-wise, it will be difficult. That is the time, that's what I'm telling you, this is the right time. Amit, as with other colleagues, they have organized this seminar because right time we have arranged. Same thing, it will be happening for high-end car also, that I don't want to go to that, but aerospace material who are working in this particular area, they have got very good future opportunity. Thank you very much.
Thank you very much, Professor Mukhopadhyay, for the kind, encouraging words. Now, I would like to invite Dr. Kumar Jatta for a few words. Let me just say something about Dr. Jatta, which is very relevant. Dr. Jatta has almost 30 years of experience working with United States Air Force Research Labs. He has been Air Force Research Lab Fellow in 2006, I think, and he has also been a Fellow of ASM International in 1998. And right now, Dr. Jatta is CEO of Jatta Materials Limited, which is a consulting company for materials related solutions for aerospace and space materials. We are very fortunate to have him here to share his knowledge about the aerospace materials, for which I don't think we can get any better qualified person. With his experience, I would like to request him to share a few words with us, please.
Thank you, Amit. I'm really humbled to be here today, really, and I'm very lucky that I got to meet the chief, the vice commander, for the maintenance here for the Air Force. Maintenance of aircraft is actually a very difficult task. It's a very responsible task and very difficult task. I used to work with a lot of the people who were in the maintenance. And the higher ups always will say, "Where is my aircraft? I want it right now." So there's a lot of pressure working with the aircraft maintenance office. And I also want to thank Dr. Jyoti Mukhopadhyay. I met him last year when I came here to visit IIT Gandhinagar, and I was very pleased to meet him. He's one of the pioneers in the aluminum metallurgy in this country, and he's also very well known abroad. And I also want to thank Amit, especially Dr. Arora, Professor Arora. I happened to meet him by chance, actually. I was visiting India, and then Amit said, "Why don't you come and visit IIT Gandhinagar?" And that was the best thing that ever happened, because I was very fortunate to get involved with him in terms of a lot of collaborations, and I'm trying to work with him more and more. And I'm very pleased to be in front of all these students, just like the commander just said. We are very fortunate to work with young people, because you are carrying the banner of the future. This country's technology and also the world's peace and everything is in your hands. We have done our job. Not that I'm about to retire and I'm very old, but what I'm saying is it is in your hands. It really is. So my job, as Professor Arora arranged this Gyan lectures for me, which I'm very humbled to come here, my job is to give you as much knowledge as I can transmit to you within the next 10 days. That is my job. So I would request each and every person, if you have any questions in your mind, if you have anything that you would like to discuss and you would like to ask me, please do not hesitate when it comes to technical things. I will be able to answer whatever I can, and if I cannot answer your questions, I will find a solution for your problems and I will try to answer them. So I'm really, again, I want to emphasize the fact that I'm really fortunate that I'm here at IIT Gandhinagar. And also I was telling Dr. Arora and also my other friend, Dr. Chandrasekhar Tiwari, that this place looks like it's very cool actually compared to where I live. It's about 10 degrees hotter than this place. I live in a desert, palm desert in California. So this weather is perfectly okay with me, actually. So thank you very much.
Last but not the least, I would like to welcome, I'd like to introduce to you the host and coordinator for this course, Dr. Amit Arora. He's currently the assistant professor in the Department of Material Science and Engineering here at IIT Gandhinagar. He has done his bachelor's and master's at IIT Kharagpur and has done his PhD from Pennsylvania State University. His current research focuses on the physical understanding of joining processes, heat transfer, and the material flow modeling. His research is also currently going on in the areas of friction stir processing and friction stir channeling. Thank you, sir, for being the host and coordinator. I would like to call you on to say a few words.
Thank you very much. I think I have said more than a few words, and we are all ready for some refreshment. Just to end the ceremony, I would like to thank Air Vice Marshal Gupta for his kind presence and kindly accepting our invitation to inaugurate the course. I would like to thank Dr. Jata for taking the time out to share his knowledge with all of us, and Professor Mukhopadhyay for his kind presence with us. I would like to wish all the best of luck to all the participants who are here for the course. We have participants, it's a very interesting mix of participants which we have for the course. We have people from industry, we have people from defense metallurgical research, we have people from the research institutes, we have people from academia, faculty members, PhD students, MTech scholars. It's a very interesting mix of students, and I'm sure we are going to have a good time in learning about aerospace materials in the next 10 days. And with that, I would like to thank everyone for being here with us. Please join us for refreshment outside. Thank you very much.